Assalamualaikum students, in today's lecture we are going to do the pH calculation of the buffer. In the previous, we did the function of the buffer, that how the buffer works, what is the buffer, and what is the formula that is used to calculate the pH of the buffer. And now we are going to use that formula, right? So if you see on the screen, there are 42 to 63 questions from the buffer pH calculations. And I have divided these into, one is when you add excess weak acid to strong base, and one is when you mix weak acid with its salt, right? The B one are easier, right? The one in which there is excess weak acid to strong base, they are a bit longer questions. Like once you know how to do these questions, you would be able to do the easier one much swiftly, right? So coming to this question, what is the formula that is used to calculate the pH of the buffer? It is pH is equal to, no, not pH. It is, I use this one. H plus is equal to Ka into weak acid over salt. Right? This is H plus. And then what you will do with H plus? You will take the negative log and you will get pH. Right? The other formula to calculate the pH of the buffer is pH is equal to pKa plus log of salt over acid, weak acid. I don't use this formula too much. I like this one more. I find it easy, this one more easier. Now, listen, the important point about this, if you see, it is the ratio of weak acid to the salt, right? So keep in mind, the ratio of the concentration is always equal to the ratio of their moles. Because in any buffer, when you make the buffer solution, the weak acid and the salt, they are in the same volume. If the total volume is same, keep in mind their molar ratios are equal to concentration ratio. Right? So what is important even in this, in both? In both, concentration ratio is equal to what? Mole ratio. This I'm going to prove even ratio. Now coming to the question. K of ethanoic acid is this much. They've given you the K value. When ethanoic acid is dissolved in water, dissolved in water, an equilibrium mixture containing two acid-base pair is formed. Write an equation for this equilibrium in the boxes. Label each species acidic or basic to show its behavior in this equilibrium. So when ethanoic acid is dissolved in water, what will form? It will lose H plus. It will gain H plus. This is acid. This is the base because it is accepting H plus. This will turn into its conjugate base, and the base will turn into its conjugate acid. Right? Now coming to the buffer question. A buffer solution was prepared by adding this much ethanoic acid, which is excess. Like the ethanoic acid is excess to this much NaOH. Hmm? So this is weak acid, agree? But is this the salt or it's a strong base? It's a strong base. It's not the salt. Like you can't put its concentration, weak acid and salt. Not at all. Incorrect. This is weak acid. It is an excess. Some of it react with this making salt. So if I explain it completely, this is ethanoic acid plus NaOH, right? They are going to react with each other in that container, hmm? Making salt and water. Now, first thing, in a buffer, there is weak acid and salt. I agree it is weak acid, but is NaOH the salt? No, not at all. So if you are adding NaOH, a base to weak acid, a base and weak acid, they're definitely going to react in that container. Hmm? I think I want to write this more neatly. Wait a minute. Let me reduce it. Now, see, 30 centimeter cube into 0.25 mole per dm cube divided by 1000 is mixed with how much? Is mixed with 20 into 0.15 divided by 1000. So 30 into 0.25 divided by 1000. 30 into 0.25. 30 into 0.25 divided by 1000. 0.0075. 0.0075. And I think this is 0.003. Huh? 20 into 0.15 divided by 20 into 20 into 0.15 divided by 1000. It is 0.003. 0.003. They are mixed. Mixed. Hmm? This is just added. So if you look at the stoichiometric ratio, one react with one. This is less. This shows that 0.003 will react with 0.003 out of 0.0075, and it will make how much salt? 0.003 formed. Reacted, finished, NaOH finished. So how much is left? 0.0045 moles left. And this is formed. So in this whole container, all the NaOH finished. This much acid and this much salt are there. Now, next thing that you must know. This whole solution is how much? 30 plus 20, 50. Like this whole solution is 30 centimeter cube added to 20. So if I go in the detail, that 0.0045 moles are present in 50. So how much would be in 1000 to get the concentration? So 1000 into 0.0045 divided by 50. And this salt 0.003 are present in 50. So how much would be in 1000? It is 1000 into 0.003 divided by 50. Now, if I put this value, salt, the concentration, right? If I use this in the formula, H plus is equal to H plus is equal to Ka into weak acid over salt. What is the weak acid? 1000 into 0.0045 over 50 divided by 1000 into 0.003 over 50. Don't you think that the 1000, 50 are cancelled? So you are just left with the moles, 0.003 and 0.00545. So is the H plus equal to Ka into weak acid moles over the salt moles? Don't you think? Huh? So what I told you, that these concentration ratios are equal to mole ratio because the total volume is always same and it is cancelled. So once you get the H plus, what is your next step? Just take the negative log and you will get your answer. Right? Now, in exactly the same pattern, this question is, look, 10 of 0.1 mixed with 10 of 0.25. So 10 of 0.25 moles, 10 of 0.1 moles, but out of this and out of this, how much reacted? This react, any of which finish, this much is your weak acid, this much is your salt. So this is 10 plus 10, 20. So are you supposed to use the total volume or that is cancelled? That is cancelled. These questions are exactly the same way, right? You're supposed to do this on your own. I'm doing another question for you. See, I have these answers and I want to do this a bit quickly. So you know what I'm going to do? For values, I will come here, okay? Look. In a third experiment, the pH of the mixture of metal ion is kept constant using buffer solution. The student prepares the buffer solution by mixing 20 of 0.15 KOH with 50 of 0.15 mole per dm cube. This thing. And this is a weak acid with a pK value. Okay, so this is your weak acid. The buffers is prepared by reacting this much KOH with this. So are they reacting KOH with this? Of course. So what will happen? So what can you think? How KOH is going to react with this thing? Is this thing containing this acid group? Yes. It's going to react? Yes. So what will happen? Exactly the same. This become what? Okay. It was already okay. So the H is removed, the OH making water. Can we make this reaction this way? Like they are saying that this is the formula. So if this is the formula, it's going to react with KOH. So what is removed? One H is removed. So it is C8H5. So it becomes H4. And O4, the K becomes what? 2. So one hydrogen is decreased and one K is increased. At the same time, what is formed? Water. Now, how it acts as a buffer? How? See, this is how much? 50 into 0.1 divided by 1000 is mixed with 20 into 0.15 over 1000. Mix. Right? So, how much are the moles? 0.005 and 0.003. This is 0.005. This is 0.003. And we know that one react with one. So 0.003 will react with 0.003, making salt 0.003. And how this is finished, and how much of it is left? 0.002. Do we have the K value? Yes, we know the pK value. So what is the Ka then? 10 power minus pKa. 10 power minus 5.4. Huh? So the H plus is equal to Ka into weak acid over salt. And then you are supposed to calculate the pH by taking negative log of your answer. Right? So you guys are supposed to do these questions on your own. I'm switching to this type of question. Look, I did this in the previous lecture. In this, the weak acid is mixed with salt directly. They are much easier. So you have acid, you have salt, you have K. Put in the formula. Same. Ka, you have weak acid, you have salt. So H plus is equal to Ka into weak acid over salt and take the negative log. Next question. See, the buffer solution in blood is a mixture of carbonic acid, and healthy blood has a pH of this. Carbonic acid and hydrogen carbonate ion. Done perfect. The pH of the healthy blood is this. This is the equation. A patient blood has a ratio of this. What is the pH? Now, listen. We have the ratio of what? Weak acid and its salt, conjugate base. We want to find out pH. We can find the pH by using either the under root formula, which is used for what? Just weak acid. But don't you think that is this weak acid only, or weak acid and its conjugate base? It's buffer. So you are bound to use this formula. H plus Ka into weak acid. So this ratio is what? 1 ratio 9.5. There are 2H weak acid and it's salt. So what am I supposed to do? Ka into I think I've made a mistake. It's how much? It's 9.51. Ka into weak acid over salt. You can get the H plus. Take the negative log, and that is your answer, pH. Exactly the same type of question is this one. See? I'm doing a few questions with you people. It's the same Ka. And this again, look at this. This is slash this. There is two H, there is one H. So this is what? Weak acid down and conjugate base or salt up. So the formula that I use is 10 power minus 7.4. H plus is equal to what? Ka into weak acid over salt. So you have to do what? Take the reciprocal. Like if I divide this by this, it's what? Weak acid over salt. Now, if I want to get salt over weak acid, what I'm supposed to do? This divided by this, and this is my answer. Finish. So it's exactly the same way. Next question. Which is a bit different. Why? Because they are using what? Mass and volume. So now what is buffer? Solution that resists changes in pH. A small amount of acid or base is added. Calculate pH of the buffer. In which what? In which this much gram gallic acid, gallate ion. So it's clear-cut weak acid and its salt. So what is your formula? H plus. You want to find out? Ka into weak acid over salt. The gallate ion is the conjugate base. It's already done, given. But in this one, what we are supposed to do, how can we find the concentration? Can you divide the mass over MR? Yes, these are moles. So 2.04 divided by 7 into 12 plus 5 plus 16 times 5. You'll get the moles in how much volume? Concentration into volume divided by 1000. Do you understand what I'm doing? Mass over MR. Moles is equal to concentration into volume. See, we are using concentration here. Now I'm going to convert this into concentration too. So what is happening? It will go there and it will come down. So actually 2.04 into 1000 divided by 7 times 12 plus 5 plus 80 and 250. Yes. Why? It will go there and it will come down with the MR. So in this way, you know the concentration. You know what? Moles is equal to what I did? Mass over MR. Moles is equal to concentration into volume divided by 1000. You get the concentration of the weak acid over salt into Ka. You get H plus, and then what you're supposed to find? pH. See this question. Look, I told you that in this ratio, you can put moles, you can put concentration because the volume is same. But why I calculated the concentration? Because if there is concentration, there must be concentration. If there are moles, they must be same. So if we are writing concentration here, we have to find its concentration over there. In this question, look. A buffer is prepared with a pH of 5 from sodium propanoate in 100 centimeter cube of water. Calculate mass of sodium propanoate that must be used to produce this buffer. So what are they doing? Is it the same 100 centimeter cube water? In which there is what? 5 gram divided by 96 moles. And now, in the same 100, I don't know the mass. Mass over MR. What is the MR? 96 moles. See what I did? I know the mass of the propanoic at 100. I want to find the mass of the sodium propanoate in 100. So what is the formula that you are supposed to do? 10 power minus 5 Ka into weak acid mm, 5 propanoic acid. I think I made this mistake. It is 70. Weak acid over salt. So can you calculate the mass of the salt? Of course. So what I did, B is converted into H plus, Ka is given. Huh? The mole ratio is equal to concentration ratio. So if I have mass over MR, I get the moles. X over 96, I'll get the mole. So I need to find what? The mass. I hope you understand the buffers questions. Now, you are supposed to do the practice of all such questions. But if you have any problem, you can contact me. You can join my live sessions. You can find the information on my website, right? Mm. And don't forget to like, subscribe, and share my channel, okay? Allah Hafiz.